Guys, are you ready for our next lesson? We are in Module 1, Unit 2, Lesson 1. And it is all about modeling with expressions. And we've already kind of been doing this a little bit with what we've been talking about in class. Every time we do a real world example, that's when we are modeling expression. So I've got this example here, and we'll come back to this. Car shoppers are always looking to find the best deal on the car they want to buy. Dealership A is offering $500 cash back on any purchase, and dealership B is offering $1,000 cash back. The tax rate is 5% at dealership A, but 8% at dealership B. How can you determine the dealership that has the better deal for a car of a particular price? And this is just another real example of how solving these equations and writing these expressions is seen every day. Every time you have a car commercial that comes on advertising their deals for the weekend or their big blowout sale, there's actually some algebra you can use to make decisions on what's the better deal. And unit rates have a lot to do with that also. So before we get there, let's talk about what an expression is. And I'm going to write down this example, and you should too. We're going to work with 7x minus 4y plus 3x. And we've got a few vocab terms here that we're going to explain using this combination of letters and numbers. And the first thing is an expression. And the expression is the whole thing. Everything we just wrote is an expression. It's the combination of terms and operations. So it's the whole thing, everything that's being added and subtracted. So the terms and operations. The next vocab we have are the terms. These are our values, and this combines both the numbers and variables in our expression. Remember, variables are our letters that we use to represent numbers we don't know about. So 7x is a term, 4y is a term, and 3x is a term. The coefficients, and I've mentioned this in another video before, so hopefully it sounds familiar, but these are the numbers in front of the variables, or being multiplied by the variables. So here, 7 is a coefficient, 4 is a coefficient, and 3 is a coefficient. And because we have variables and numbers, we have an algebraic expression. So if it has numbers and variables, it's an algebraic expression, whereas a numerical expression is just something like 7 minus 12. It only uses numbers. So those are all of our vocab words we're going to use for this chapter and moving forward. So here's our first example. I've got 8p plus 2q plus 7r. All of my terms included are 8p, 2q, and 7r. So remember the terms, and you can kind of split them using the operation. So anything that's between the operation symbols are all the numbers in front of your variables. So here it would be 8, 2, and 7. So now you guys give this one a try. So our terms include 18, 2x, and 4y. Everything, even if there's not a variable, counts as a term. The coefficients, though, are only 2 and 4 because it's only the numbers in front of the variables. Six Flags are up to $60 for adults and $30 for children. If A is the number of adults and C is the number of children, then the cost for all of our adults and children is represented by this expression, 60A plus 3C. All of my terms I only have two. I've got 60A and I've got 30C. My next question, though, is what are the factors of 60 times A? So remember, factors are what can be multiplied to get to that number, or in this case, what gets multiplied to get to 60A. And the factors would be 60 and A. It's what's being multiplied. So the factors of 30C would be 30 and C. And my coefficients will be 60 and 30. So moving off of this, we're going to talk about, this is still in the same section of notes, modeling with expressions, but now we're talking about in context. And every time we say in context, what we really mean is in the real world. Where are we going to see this? Why are we going to use this? And here is my first, and this is a big example, so make sure you have space for this and keep yourself organized. Jill is buying inkjet paper and laserjet paper for her business. She buys 8 more packages of inkjet paper than P packages of laserjet. Inkjet cost $4.95 per package, and laserjet costs $8 per package. So I've got this whole big expression here of 8P plus 4.95 times P plus 8. And I want to know what that whole thing represents. And we're going to walk through this a little bit. Before I do that, I'm going to go back and annotate what information I have. So this first paragraph tells me that inkjet, she has 8 more packages than the laser. So I'm just going to write this out in words. And this is what is worth writing down in your notes, that my ink packages is equal to 8 plus the laser packages. I also know that instead of the laser packages, I'm going to replace that with my variable P because that's what the directions tell me to use. So ink is equal to 8 plus P. I also know, now getting in terms of cost, that my inkjet paper is equal to $4.95 times the number of packages. And my laser paper is $8 per package. So the first question to help us break down this whole big expression is, what does 8P represent? And this would be the $8 times the number of P packages of laserjet paper, which means the coefficient 8 represents the cost of laserjet paper. So that's piece number 1. That was our first term answered in these 2 questions. Then we move on and we have kind of a bigger piece of our expression, that 4.95 times P plus 8. Remember, parentheses represents multiplication. So this whole thing is my cost times the number of ink packages. And the reason that it's P plus 8 comes from up here, where they told us it's 8 more than the laser packages. So 8 plus P. So now I'm asking to interpret the expression 8P plus 4.95 times P plus 8. What does the whole expression represent? And I'm going to label your 4 options here as A, B, and C, and you're going to decide. Hopefully you chose B because it's the total cost of packages of inkjet and LaserJet paper. It's both costs all together. So I'm going to let you try to break this one down. George is buying watermelons and pineapples to make fruit salad. He wants to buy W amount of watermelons at $3.69 each, and he's going to buy P number of pineapples at $4 each. So here is my expression, 3.69W plus 4P, and I want to know which of these options does that expression represent? Again, it's the total cost of both the watermelons and the pineapples all together. For this one, I would say that my pencils is equal to my pens minus 2. So here I have that in my expression. Then I know my pens cost $4 each. So 4 times the number of packages, which means this expression tells me the total cost for both pens and pencils. So now we're back to talking about the car prices. What's the best buy? There's taxes, there's cash back options. Let's just talk about the price of a car plus an 8.5% sales tax. I'm giving you the verbal expression here, the base price of the car plus the 8.5% sales tax on the quantity of the car. So take a guess, and this is how we'll mark these: A, B, C, and D. So a couple of things to think about in solving this one, and I'm going to let you answer again in case you think maybe you got it wrong. So I'm going to explain a little, and then you're going to answer. The first thing is the base price of the car. We're labeling that as P, so I know that's the first part of my expression. Then I have to add the 8.5% of the price. And if you didn't know this before, of is usually a symbol of multiplication, which means I have to do the 8.5% times P, the price. So I've got the price plus the tax times the price. And the one other thing to help you answer this question is when you are changing a percent to a decimal, which is what we need to do in order to multiply, we have to move our decimal place 2 over. So in this case, C would have been the correct final answer.